Good morning, students. This is Ban Prasad, working as Assistant Professor in Department of Mechanical Engineering in MBA College of Engineering and Technology. Today, we will discuss about what is deburring and ECM, electrochemical machining process. So what is ECM1? So what are the advantages and what are the applications and what are the disadvantages and what are the MRR in ECM? What is the material requirement rate we are used in ECM1? So it is our today class one. So let me start for deburring. So what does burn means? So we have the doubt. So deburring. First of all, we want to know what is burn. So burn means burr sharp edge resulting from cutting and stamping operations from. So burn is nothing but sharp edges. So it is a sharp edge one. So you see here edge after deburring tool is used one. So before one. So it is before one, we can see it is one of the roughest material. So roughest one we can see here. This edge one is very, very rough material, this one. So when we are doing the burning process, deburning process, we can see the material edge is very smoothness. There is a major difference here. So burns are sharp edges. So it is sharp the edges one resulting from cutting stamping operations. How can we do the deburring means resulting from cutting and stamping operations we can do in this deburring process. So although usually small in size, so although it is in small sizes, burns can causes assemble problems only. So how the burns will be causes means it is based on the assemble process. Assemble process, disassemble process we have. Mainly assemble process onwards, we can see these kind of defaults in the machineries, defaults in the parts one. So after then only by using this process one to resolve these kind of problems also. So the interfere with fluid flow and are a common causes of worker injury one. So burns can also cause increased stresses and subsequent failure of the part one. So burns also causes another reason we have. So increase the stresses. When the stresses are increased in the material one, automatically this kind of defaults we can see on the metal one. So another subsequent is nothing but failure of the part. So another default of the burns means how the burners how the burr causes means one of the default is one failure of the part one. So often also the burn will be causes here. So it is what introduction about the burn. What is the burn? So how the burn will be causes here. So in this slide we discuss that one. So burn will be how can we do the burners means cutting and stamping operations. We can do the burning one. So how the burner will be causes means it is one of these all through assemble process, mainly assemble process. It will be farmers one. Second one is increase the stresses one. Second one and next another one is effective failure of the part one. Based on the three regions, the burn will be causes here. First one is assemble parts, assemble problems. So next one is increase the stresses one. Third one is effective failure of the part one. So these three reasons the burn will be formed up here. Burn is nothing but here edges, sharp edges one. Burn are sharp edges one. So it is one metal one sharp edges onwards. We can see it is before deburring tool is used here. So after deburring tool is used here, then we can see the difference here. Surface differences. Majorly we can see here surfaces differences before deburring, after deburring. So next one is we can see what is the deburring process. So burn, that is the definition. What is the deburring? Deburring is the finishing process. So it is one of the finishing process that are used to prepare metal or wood for finishing. So which kind of material we can use it means so it is wood, metal or wood we can use it for finishing operations one. So this is the definition of the deburring. Deburring is nothing but one of the finishing operations. It is used to prepare metal or wood for the finishing operations. Metal or wood we are used in the finishing operations one. It is in olden days when materials were cut or pieced, a rough edge would be left one. So in olden days, when we cut any kind of material one automatically, so what happens? So when we cut the material one automatically, we can see some roughness on the material one. So that is in olden days. That is called as the burr. That is called as the burr one. So in olden days, there is no technology one. So after then they can use it for any kind of on material, any kind of part they are using and cut the material one. So after cutting of the material, we can see the edges are very roughness only. So after then the burn will be forming there. So it is a major one, Amma. So this is called as burn one. The process for removing these edges is called as deburning. When the rough edges will be formed there. So when we remove the sharp edges one, so that one we can call as the removal of this edge is called as the deburning process. So the edge in the olden days they can cut the piece one automatically. The sharp edge, rough edge will be formed there. So by using the deburning process to smooth the rough surface area is called as the deburning process. So that is a definition, a major definition. Burn is there is the previous slide we discussed about burn one, but here we are discussing about deburning. How the deburning is one of the finishing operation one. So in olden days, any one metal we can cut automatically. We can see roughness on the metal one. How can we remove the roughness? Means by using this deburning process, we are removing the roughness area one. That is one of the finishing process. So it is overall deburning definition and important points. So this can be achieved by filling, sanding, wet and dry, preparing the edges until smooth one. So it can be achieved by filling the sanding. So rotary or sharp sandpaper one. Sandpaper we can use wet and dry, preparing the edges until the smooth one. So this kind we can use it and will smooth the surfaces one. So in general, most modern metals are deburned in the production one. So in general, most modern materials, are deburned in the production one. Most modern metals nowadays, where you are manufacturing so many modern parts. So many parts we are modeling one. So the model materials are deburned in the production also. So the process like laser cutting, what are the process we can use? It means laser cutting leaf and excellent finishing. So in laser cutting process is like laser cutting so leaf, and we can see an excellent finishing we can see on the this process some. So it is the deburning process one. So next one is burn removal, or we can call as deburn, is a standard practice associated with virtually every segment of the manufacturing process. So it is one of the standard practice summer. So it is one of the standard finishing operation. You can use it for any kind of production operations one. So any kind of production manufacturing system. So we can use it for deburning. Deburning is one of the finishing operation one. By using this one by using the deburning process to smooth the rough surfaces one. Rough surfaces are becoming smooth surfaces when we can get means by using the deburning process. So it is the majority of deburning is performed using the mechanical deburning process, but thermal deburning and electrochemical deburning process also we can use it one. Mostly majority deburning process is based on the mechanical deburning process we can use it, but thermal deburning and electrochemical deburning process also we can use it. So we have the deburning process, different kind of. First one is mechanical, thermal, and electrochemical. So these kind of operations we can use it for any kind of production systems. So it is deburning. So next one is we can see block diagram of deburning one. So it is electrochemical deburning one. So see here, so it is burr this one. It is sharp edges one. So see here, this unwanted material here. These sharp edges we can see here. Clearly mentioned it is burn one. So it is a tool one. Tool is not always act as it is a cathode one. So what is always act as anode one? So it is a insulation one. So it is electrolytic flow. Electrolytic flow is in electrolytic flow always we can use it for fluid, water, oils, whatever it may be. It is electrolyte one. So electrolyte passes between the workpiece and the tool one. So the workpiece and tool, we have some gap one. In this gap one, the electrolytic flow will be passes thoroughly. So see here, it is a tool one. So when the tool will be moved from forward and backward, after then, so the workpiece surface will be changed here. The rough surface becoming smooth surfacing one. So it is one of the finishing operation, Amma. So it is the parts one. First one is cathode is nothing but tool, anode is nothing but workpiece. So is the insulation one. So it is electrolytic flow. It is electrolytic one. It is a burn one. So when the tool or cathode material move for upward and backward one, so after slowly the surfaces, the workpiece surfaces will be changed slowly. After a certain time, we can see smooth surfaces, good surfacing finishes we can see on the this workpiece one, these kind of materials. So it is a deburring process, one of the block diagram one. So see here, electrochemical deburring one, it is an adaptation of ECM designed to remove the burns or round shaped corners one. So it is the adaptation of the ECM one, electrochemical manufacturing one. It is designed to remove the burns or round shaped corners one by anodic dissolution one. The hole in the work part as a sharp burn. The hole in the work part as a sharp burn one. So the tool is designed to focus on the burn one. The tool is machine should be designed to focus on the burn one. That is major difference here. The portion of the tool not being used for machining or insulated work. The tool we have the tool one. The tool is not being used for machining or insulated one. So that is a major difference here. So next one is the electrolytic flow through the hole to carry away the burn one. The electrolytic flow through the hole to carry away the burn one. So that is the electrolytic flows one. You can see here. The same operation principle of ECM also applied to ECD. However, circle times are much shorter one. So the circle times are shorter one. So the operation, same principle operations are when used for, we can apply for ECM, electrochemical machining process also. So the typical cycle time is less than a minute one. The cycle process is less than the minute one. We can see the total circle, electrolyte and everything is flows in a less than a minute one. The time can be increased if the desire to round the corner one. And the time will be increased one, it is designed to round the corner one. This will be round. So it is one of the electrochemical deburring one, ECD. See here another block diagram of ECD. So detailed diagram. So workpiece, always it is a workpiece is major one here. So it is a burn one. So it is a tool one. Tool is act as cathode one. The workpiece act as anode one. It is electrolyte one. It is electrolytic flow. The electrolytic flow flows like this. So it is through the it is flow for the between workpiece and the tool one. So total surroundings, total surrounding. So the electrolyte will be the electrolyte fluid will be flowing here. So it is the electrolytic deburring one. So the tool move for forward and backward. So after then only, so the rough surfaces will be removed here to get smooth surfaces after certain time onwards. So this process we can call as the deburring process. So see here, the tool will be moved for backward and forward, backward and forward, backward and forward. After then only we can get here deburring process. So it is one of the block diagram. So next one we can see. So it is our deburring concept, Amma. So here in the second unit one, totally we have the three kind of topics. One first one is ECM, electrochemical machining process one. Next one is ECG. So ECG, electrochemical grinding one. Next one is ECH, electrochemical honing one. Next one is ECD, electrochemical deburring one. Totally we have the four topics in the second unit one. So very important one. So here major one is ECM one, electrochemical machining process. What is the fundamentals of ECM one? What are the advantages? So what is the economics? What are the economics of MRR one? What is the material requirement rate in ECM one? So what are the applications? What are the advantages? So and we have the MRR based on we have the some of the sums also in this second unit one. So unless we start for ECM one. So it is completed. Deburring topic also completed. So these topic are what in second unit majorly 99%. 4 topic is completed. So remaining 1% is ECM sums. So that is a major one. How can we get the how can we know the ECM sum means? So go for MRR1 material requirement based on. So we have the on derivation part based on we have the sums. So let me start for ECM again one. So see here electrochemical machining process. So electrochemical machining process is one of the newest and most useful non-traditional machining process belongs to electrochemical category. So in electrochemical, our unit is also electrochemical category one. So in electrochemical category one, ECM is the one of the newest and most useful non-traditional machining process. So one of the newest advanced one. So nowadays mostly we are using for ECM one. In olden days they are using for conventional machining process only. But nowadays they are introduced the different kind of machining operation one. That is the one of the ECM one. So electrochemical machining is used to remove the metal. It is ECM is why we can use it for ECM means by removal of the metal one. So which kind of material it will be removed means alloys which are difficult or impossible to machine by mechanical machining process. So it is can be different kind of materials we are using here alloys. So which are difficult or impossible machine by mechanical machining process. So some of the parts we cannot be machined. Why? Because so we can see some of the defaults. So some example one unconventional machining process we have. So some complex shapes, some difficult shapes we can manufacture on conventional machining process. Some of the drawbacks we can see on the particular machining operation. So that's why some of the delicate parts, some of the different complex shapes of the parts you can manufacture in ECM one. So that is a major one. So the reverse of electroplating also we can use it here. The machining operation is based on, so the total working ECM is based on the sum of the formula, the Michael Faraday's classical law of electrolysis. So based on this formula and what's the total machining is operating one, the machining is processing one. So requiring basically 2 electrodes. So basically we can use it for 2 electrodes and electrolytic a gap and a source of DC power of sufficient capacity. So electrolyte gap also we can see. So and source of DC power we can use it in the ECM one. So in ECM process machine should we can use it for DC power supply. So and electrolyte we can use it and electrodes also we can use it in ECM one. So it is one of the ECM process. So ECM process mostly we can use it for alloy materials one. So some difficult parts. So some of the complex shape parts one we can manufacture here. It is one of the newest and traditional, non-traditional machining operation one. So next one is we can see here the major one is material removal rate. So it is one of the very important topic in the second unit one, electrochemical machining process one. Based on this formula one, we have the sums. So next class we can continue for this topic sums one. So we can complete the sums. The total second unit will be completed here. So this is one of the very important topic one. So in the second unit one, based on this concept onwards, we have the sums. Final exam sums they will ask you. Metal removal rate onwards they have the sums. So metal removal rate MRR. So each and every process we have the MRR, very important one, material requirement rate one. So it is an important characteristics to elevate efficiency of the non-traditional machining process. So it is one of the most important characteristics to elevate efficiency, to elevate the efficiency of the non-traditional machining process. The elevating efficiency purpose, they introduced this MRR one, material removal rate one. So in ECM one, material removal rate take place due to atomic. So automatically the ECM will be takes place here. So dissolution of work material, which is governed by Faraday's law of electrolysis one. So we have the one formula one based MRR by EC in ECM one. What is the MRR means? So see here M by TP equal IA by F rho V1. So here M is nothing but I see here ITA by F suffix V1, mass of material dissolves one. So I is nothing but current here. So A is nothing but atomic weight here. A is nothing but, so V is nothing but here valency one. Next one is F is nothing but Faraday's constant one. So F is always constant. How much means 96,500 Columbus one. So rho is nothing but density one, always density of the material one. So it is a formula one, MRR. MRR in ECM means M by T suffix rho one. So next one is IA by F. F suffix rho, F into rho into V1. So it is a formula for the material removal rate one. So next one is what is the economics products of what is the economical consideration in ECM1. So the process is economical one. The ECM process is an economical one. There is a large number of complex identical products are to be made one. So when a large number of complex and identical products are to be made in ECM1. So it is one of the very important point. One, it is one of the economical process. ECM is one of the economical process when a large number of complex and identical products are to be made in ECM1. So large cavities are mostly economical one. So large cavities are more economical on ECM1 can be made in 1 by 10th time in EDM1. The two most common products is turbine and compression blades, refill barrels. So these are the most products you can manufacture in ECM1. So by using ECM1, mostly we can do the products means this one, turbine and compressor blades. Another one is refill barrels. Mostly we can manufacture, mostly we can produce it one by using the ECM1. So next one we can see what are the advantages of ECM1. So it is a very important one. ECM is well suited for the mission of complex two-dimensional shapes one. So very complex shapes for two-dimensional parts manufacturing purpose we can use it for ECM1. That is one of the main point one. Delicate parts may be made. So one of the delicate parts, or we can call as brittleness parts also. So that parts also we can manufacture in ECM1. Difficult to machine. So very difficult to it will be machine here. It is a geometries. You can see here purely machinable materials can be processed here. Purely machinable parts also, purely machinable materials are is may be processed here. So little or no tool wear. Little or no tool wear we can see here. So mostly the tool we can use it for continuously we can use this kind of tool here in ECM1. The tool will be not changed here. The tool continuously we can use it in ECM1. So disadvantages also we can see here. Initial tooling can be see here. Initial tooling also we can see here. Timely and costly one, as it is a time consuming process, very costly process also. Environmentally harmful products one. So environmentally, we can see some of the harms here. Complicated tool will be designed here. Large power consumption we can see here. So in ECM1, we are using for power supply. So DC power supply we are using one. So that's why the power consumption and we can use it for more in ECM1. So next one is some of the advantages here. So next one is applications see here. The most common application of ECM is high accuracy duplications because there is no tool where it can be used repeatedly with a high degree of accuracy. Majorly, so we can see ECM high accuracy, efficient, high accuracy and good surface finishing parts we can see in ECM1, but there is no tool where here, so it can be repeatedly used and with a high degree of accuracy. The tool will be used for repeatedly with a high degree of accuracy onwards. This is one of the application. It is mostly used for thin valid, easily deformable and brittle materials because they would properly develop cracks with the conventional machining process. So some example one, very mostly commonly you can use it for thin valid and brittleness materials. You can use it in the ECM1. So the brittleness material and thin valid materials you can use it for conventional machining process. So some of the drawbacks, some of the cracks you can see on conventional machining process. So that's why the delicate parts, thin valid parts, brittle materials you can use it in ECM1 only. So it is used in machining of hard heat resisting alloys one. So is used in machining of hard heat treated resting alloys. We can use it in ECM1. It is used in cutting cavities. Mostly it is used for cutting cavities. Holes in various products. One machining of complex external shapes. One like turbine blades, aerospace components, and machining to tungsten of carbides, nozzle of alloy steel. One. So these parts manufacturing purpose machine sheet we can use it for ECM1. The first one is holes in various products of machining one. So complex external shapes like that turbine blades is very important one. Aerospace components one. Machining of tungsten carbide one and nozzles of alloy steel. So these parts are made in ECM1. So any conducting material can be machined by this method. Any kind of material can be machined in this method one. In this method is nothing but ECM1. Any kind of material it can be machined in ECM1. So next one is what are the disadvantages? High energy consumption is one. So non-conducting metal cannot be machined here. Non-conducting metal it cannot be machined here. Corrosion and rust of ECM machines can be hazarded by measures can help in this regard one. Corrosion and rust of ECM machine can be hazards. So the corrosionals will be forming here and simultaneously we can prevent by using some of the precautions ones. So it is one of the disadvantages one. So high energy consumption is a major one here. So next one, it is our total ECM1 mama. So it is our ECM1 topic one. So ECM1 in ECM1 MRR we have the topic one. MRR based on we have the sums. So we can solve these sums one. So totally second unit is completed one. So it is overall or second unit one. Only one topic is remaining. That one topic is nothing but sums. MRR sums. The economical accepts of ECM in MRR. So the MRR sums we have. So tomorrow class we can continue these sums and complete the second unit one. Thank you, Amma. So it is our today class. So today class we will discuss about ECD, electrochemical deburring process. So what is deburring process one? So what are the advantages? What is working principle? What are the disadvantages? So that one we can discuss that one. So another topic is ECM1. What is the ECM1? So in ECM1, what is the key role of MRR1? Next one is what are the advantages? What are the disadvantages? What are the applications of ECM1? So it is our today class. Thank you, Amma.